Hi, this is Mr. Max. So today I'm doing the second part on my three-part series on linear programming, also known as linear optimization. Right, so there are a few things or stages that I want you to remember whenever you're dealing with linear programming problems, especially word problems. Most of the time, it's going to take this type of thinking. You have to interpret the information and then you must write the inequalities. And then you have to graph the inequalities. Remember, when you graph the inequalities, it's straight lines. When something is included, it's a solid line. When it's not included, it's a dotted line or a broken line. Then you shade the unwanted regions in order to find the required region that you will work with. And then you find the maximum or minimum point in the required region, inside the required region. So I'm going to do a few questions, but there are a few things I want you to remember when you come across some words. Things like at most. When you come across at most, it means then, it's less than or equal to 10. So 10 is the maximum, if I was to use 10, that the information can go to. If you use at least, that means you can have more than that 10, but obviously that 10 is included. So if you say at least 10, it can be more. It can be 12, it can be 13, but the minimum value there is 10. It's going to be the constraint there. A minimum of 10, exactly the same as at least 10. A maximum of 10 means 10 is the cut-off. Cannot go over that particular value. Not less than 10, these ones are quite straightforward. Not less than 10 means can be greater than or equal to 10. And not more than 10 means can be less than or equal to 10. And then more than, this is where you only have the inequality without the or equal to, or less than. And you know exactly. When you come across these words, it's advisable that you use this type of words to help you to remember how to write inequalities. Right, so I'm going directly to the question. So I'm going to do question one. So this question here is about a car hire company, and they have got X small cars, so that's going to be on my X-axis, and Y large cars, that's going to be on my Y-axis. And the company has at least 6 cars. That means if you add your X and your Y cars together, X plus Y should be at least 6. That means they can be more than 6. All right. Then the number of large cars is less than or equal to the number of small cars. And another inequality is the largest number of small cars is 8. So we are supposed to write down the inequalities. So the first part is X plus Y is greater than or equal to 6. And Y is less than or equal to X, the larger cars. And the larger number of small cars for X is less than or equal to 8. So the small cars can just be 8 or less than that. All right. So then you have got another sentence here that says a small car can carry 4 people, so that's going to be 4x plus 6 people, that's going to be the larger car, 6y, so it's 4x plus 6y should be less than or equal to 60, and then you simply simplify that particular inequality by dividing throughout by 2. It should give you this 2x plus 3y is less than or equal to 30. So you have got 4 inequalities in a nutshell that you need to draw. Right, so I have here all the 4 lines or the 4 inequalities that I have written down. So I am going to draw the lines, and then I'm also going to shade the unwanted region. All right, so and then I'm going to show the region that is required. I'm going to indicate that by putting an R there. So let me bring in a grid. So obviously I'm going to label it, but I'm labeling towards the end, but you can start labeling it already. The X is the small cars and the Y is your large cars. And I'm going to draw the lines. For example, the inequality Y is less than or equal to X is a straight line Y equals to X, so that is the line here. Now whenever you are drawing the inequality, okay, so when you draw the inequality here, you're looking for the region that is the unwanted region is the region that we are going to shade. All right, so in this particular case, the unwanted region is above the line because every value here is not true for the inequality. All right, so if you perhaps pick that particular value here, you will realize that Y is 9 and X is 4 and Y is bigger than X, okay, and that is not what we are looking for. So this is the region that is that you are going to shade when you do this particular line. So the next one is the line x plus y equals to 6. Now you can find the solution to this line by simply making x to be 0, then you find the y value, then y is 6. All right, once you have that, the point 0, 6, you can plot that point. It's going to be here on the y-axis. Then you make y0 in order for you to find x. Then x is equal to 6. So that's going to be 6, 0. So this one is quite straightforward to draw because the line is going to cut the x-axis as well as the y-axis at 6. All right, so then you draw and produce that particular line. All right, so now I have done the second one. So to do the third one, a little bit tricky, but the third one is straightforward. It's simply the line x equals to 8. And when you draw that line, or before I continue, perhaps I should shade my unwanted region for the second equation, x plus y equals to 6. Now, if you look bigger than or equal to 6, so we are shading the region below, because if you pick here, you realize that x plus y is not going to be bigger than or equal to 6. So this is going to be 6. Let's say this is x is 3 plus 1. So when you have your 3 plus your 1, you get 4, which is not true. All right, so this is the unwanted region. So this particular region here, for that second line, you are going to shade below the line, okay, because the wanted region is above the line. And the next one that we are going to do is the line x equals to 8. X equals to 8 is a vertical line like that. And the inequality says values of x that are less than 8. So on the right side of the line, these values are bigger than. So you shade then. This is the region that is not required. All right, you'll be shading that particular region. Okay, so we're getting very close to finding our polygon. All right, and then we still have a third line, which is the line 2x plus 3y, all right, is equal to 30, coming from that previous question towards the end. So again, you can manipulate this. Maybe you can make x to be 0, and then you calculate what y will be. When x is 0, then y is going to be 10, because you will be dividing 3 into 30. So that is a point that you can have. So you can have a point 0, 10, which is way up here. That is the point that we are going to plot if you were to draw that particular line. And also to find where the line will cut the x-axis, you make x equals to 0. So that means you will be taking, you'll be saying 2 x, you make y equals to 0. So plus 3 times 0. And obviously you are going to end up with 2x is equal to 30. And if you solve for 2x equals to 30, you realize that x is equal to 15. So the point then that you are going to draw is going to be the point 15, 0, which is way down here on the x-axis. And once you have that, you just then draw that line. Okay, so the values that are less than or equal to 30, it's going to be below the line. So the region that is not required are the stuff that is above the line. All right, so then you shade that stuff that is above the line, and you realize that the polygon that we are looking for, the value of r, or the r, is right here, the part that is not shaded. All right, so it's right here. So this is where we are going to look for our solutions. Say, for example, we are asked to find minimum values and stuff like that. Okay, so let's look at that same diagram. I'm just going to bring it back here. So remember our diagram, the way it was shaded. The part below was shaded here, okay, as well as the part above was shaded for that particular line, as well as this part was shaded for that particular line, and then for the vertical line, the part that was shaded. So our region was this part that you can see that I have left unshaded. Okay, so we are supposed then to find the number of small cars and number of large cars needed to carry exactly 60 people. So exactly 60 people, so 4x plus 6y. So you have to pick points. Now you can pick your points, but you don't have to go so far to find those points. All right, you can perhaps, right, as I was saying, you can then choose a point. It's either you choose a point 6,6 or you choose the point 3,3. You don't have to choose all of these other points that are in here. All right, you choose the one higher up. When you choose a point that is higher up, it's normally going to give you that maximum or the highest one that you get. Right, we're going to see that that point 6,6 is the one that if you sub it in here, 4 times 6, you are going to get the 24. So when you are saying 4 times 6 here plus 6 times 6 here, you are going to get 24 plus 36, and obviously that's going to give you the 60, and that is the required point. So the point 6 is what you are supposed to use. So the other points that you would have considered, again, as I said, you don't have to consider each and every point. All right, you don't have to consider this point or so on. You just take the points at the extreme. So it's the one higher up is going to give you the solution for the maximum anyway. Right, so now if I bring my diagram, my completed one, so you'll be labeling it here. The y-axis is the large cars and the x-axis is the small cars. So we are saying the company uses 7 cars. So that means it's large cars as well as small cars. Now I want you to look at the combination because we have to find the largest number of people that can be carried. Right, so if I look at whatever gives me 7, it's the point 7,0, which is right down there. That's going to give you 7. All right, that is 7 small cars and no large cars. And if I substitute in to that, I'm getting 28 people. The 4 times 7 is the value of x times 6 times y is 0. I get 28. I pick all the points that add up to 7, okay? So 6,1 is the next point I'm going to consider. And if I sub again the x value for 6 and the y value for 1 into 4x plus 6y, I get 30. And another point is 5,2. That is also adding to 7. And if you substitute that point into your expression, you get 32, 4 times 5 plus 6 times 2. And the last one that you have here is 4,3. They also add up to 7. And if you substitute that one in, you get 34. And from here you can see that 34 is the largest number of people that can be carried. And that's how this particular question is supposed to be done. Right, so I have a second question here. Lucas wants to buy X goats and Y sheep. So that tells you exactly the X is for the X axis, the Y is for the Y axis. He wants to buy at least 5 goats. All right, at least, that means he can buy more than that. So X greater than or equal to 5. So when you write that down, that is how you have the inequality. Then he wants to buy at least 11 sheep. So sheep Y is greater than or equal to 11. So that's the other inequality that you have to write down to represent this condition. Then he wants to buy at least 20 animals. That means the sheep plus the goats should be greater than or equal to 20. These ones are quite straightforward. Right, then there is a B part that says goats cost 400 Namibian dollars and sheep cost 800 Namibian dollars. And Lucas can spend 16,000. All right, so when you write down it's 400x plus 800y, should be less than or equal to 16,000. 16,000 is the maximum amount that he can spend. He cannot go over that, so the inequality must be less than or equal to. Right, so 400x plus 800y is less than or equal to 16,000. When you divide throughout here by 400, because 400 goes in 400 and 400 goes in 800 and in 16,000, you are going to end up with x plus 2y less than or equal to 40. So at least now you have got 4 inequalities that you can represent on a grid. Right, so I'm just drawing a quick sketch here. They are saying we're supposed to use a scale, so we're going to have 5 units on each axis, and we are going to draw those inequalities. So for example, the inequality x plus 2y is equal to 40. This is going to be the one that cuts the x-axis. If y is 0, it cuts the x-axis at 40, and if x is 0, it cuts the x-axis at the y-axis at 20. So you can draw that particular line. We're going to do that when we have our grid. And another one is x plus 20. X plus y is 20. That line here obviously is going to cut at 20 and 20. Like the previous one we had. And then you have another one, x equals to 5, that's just a vertical line that will be drawn, and y equals to 11, that's a horizontal line. And then you will be shading, obviously you will be left with a region that is required. That region is either polygon or triangle, but whatever that region is, and we are going to look at that particular region for answering further questions. Right, so they are saying we're supposed to work out a maximum number of animals that he can buy. Right, so let me just bring in, so this is my x is less than or equal to 5 or greater than or equal to 5. So I shade on the left side of that. The other one was the line x plus y is 20, so I shade below. The other one was the line y equals to 11. You also shade below. And then there was the line the one of 20 and 40, and you can see the polygon that I require is this region here, and from that region we are going to then write down questions. So not all the points need to be tested. You only test the points that are higher up if you're looking for the maximum. So higher up points, you don't have to go and pick all the points in that region. All right, so I choose this particular point here, and it is not exactly on because the line there doesn't cut really. It's a little bit below, so I've decided to use the point 5 comma, it's about 17 here, and when I add I get obviously 22, and the other one here also exactly, it's not under 20 exactly, but it is something like a point 18 there and 11. All right, so those are the 2 points that if your grid is drawn correctly, should be the points that are higher up. We pick those points. No use to pick this 2 below here because it's lower, so the value will not be high as well. All right, so when you add, then you realize that the particular point we're looking for, 18 plus 11 gives you 29. That's the maximum number of animals that Lucas can buy, so he can only buy 29. Okay, so that 29 comes from the point 18 and 11 here. So normally it will be a bit clearer in the examination. You should be able to find this point, but higher up is where you find maximum value, and lower up you then go to the lower part of your region there.